Alright, so hello and welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 4 here, which is asking us to determine the moment of the force about point O. So I've recreated the diagram from the textbook on the kind of center of the page here, just so that we can draw all over it basically. Now, we can note from the start that we've got one force acting here, this 600-pound force, and conveniently, I suppose, it's not acting diagonally. We don't need to decompose it, right? It's just acting vertically. And about point O, it's going to be enacting a anti-clockwise moment, right? We note that if, let's say, we were to kind of imagine ourselves placing our finger on point O here, this 600-pound force would be rotating the paper anti-clockwise, right? So it's an anti-clockwise moment. And since it's an anti-clockwise moment, the perpendicular distance from point O that we're interested in here is this length here, right? So let's just kind of add that to our diagram here. We're interested in this length here. We note that we've already kind of made 4 feet of progress here. And so we're even maybe more interested in this length here, right? So to determine this length, we note that from this point here, we have a 45 degree, we have a 3-foot length acting 45 degrees to the horizontal and kind of downwards here to this point here. And then we have a 1-foot length acting to the left. This is useful information. We're working with a 45-degree angle to the horizontal here, and 45 degree angles are very convenient. The reason that they're nice and convenient is because we note that this angle here, for example, is also going to be 45 degrees, since they sum to 90, and this length here is going to be equal to this length here. That's how it works with 45 degrees degree triangles, right? It goes just as much down as it goes across. So we could label this side A, this side B. We know that they're equal to each other, but we'll get to that in a sec. And we could label this side C, since it's the hypotenuse. A squared plus B squared equals C squared, right? This is elementary stuff. We note, however, that A and B are equal to each other, so we could erase our B label there and just put in an A there. And we can kind of reformulate this idea and say that 2a squared is equal to c squared. We note that c is equal to 3, so we could say, therefore, 2a squared is equal to, just call it 9. We can rearrange for a, so we could divide both sides by 2 and square root both sides. So we can say a is equal to the square root of 9 over 2, right? Now, when we bung this in our calculator, I know it gives us something that looks like this in third form, and we can also decimalize it to something like 2.121. Okay, so we know then that this length and this length are both equal to 2.121 roughly, right? Let's just add that in. So if we're trying to find this length from earlier, right, we could say that at least in the horizontal dimension, we have this 2.12 length here, and then this 1-foot length here. So we could say that this length here is equal to, or roughly equal to, 2.121 minus 1 foot, right? I trust that you guys can see that. So we can do that by inspection. That is equal to 1 point, this length here then is equal to 1.121, okay? Okay, so if that length there is 1.121, then this length in its entirety, then I trust you guys understand, is roughly equal to 5.121. Okay, well, we can say then that the sum of moments about point O acting, let's say anti-clockwise here, is equal to the product of this 5.121 length and this 600-pound force, okay? So we can just multiply these together, which gives us a rough solution of 3,072.6 pound-feet. And that's our solution there. In the back of the textbook, it gives us a solution in this form here, it's written like this. Why kilopound feet is written like kib foot, I have no idea. I'm not very familiar with imperial units, but there we are, 3.072 kib foot. If you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.